Hi Calculus. Okay, this is now the third video on integration. So I hope you remembered when we learned the power rule for derivatives was that you can't have the, there's no quotient rule for integration, so we have to actually break this down. Okay, so I'm just putting everybody over x to the fourth. Now I'm going to reduce everybody. I don't particularly care too much for this problem the way it's formatted, but I'll just show you so you can see it. And now again, you have to bring everybody upstairs for integration. Okay, so I've now brought all the variables upstairs, and they're all negative because they came from the denominator. All right, so all of this was just the rewrite step. That's what I did all this for. I'm actually going to take the derivative here at the bottom. All right, here we go. So now remember, you have to add 1. So when you add 1 to negative 2, you're going to get x to the minus 1. You have to divide by the new exponent. That's how you do integration. And let's just go ahead and rewrite this while we're at it. So that means that this guy's going to flip down. So this negative exponent means it flips down. This negative like coefficient, I would just bring this up like this. All right, let's try the next one. We're going to add 1. So that's going to be negative 3 plus 1 is negative 2. We divide by the new exponent. So this is going to, the 2 and the 2 will reduce, the positive and the negative make a negative, and the x flips down. Just in case I said that too fast. The 2 and the 2 reduce, the positive times the negative makes a negative, and the negative exponent flips this guy down. Alright, next guy. Alright, we're going to add 1 to this guy, make that a negative 3. Divide by the new exponent, which is a negative 3. Alright, the 3 and the 3 cancel each other out. The double negative makes a positive, and the x is going to flip down. And did you remember? At the end here, we're going to add the plus c. I don't need you to get an LCD. That's fine. You can leave it like this for test 3. But just so you know, your book is actually going to get an LCD and balance all this out, okay? So just, you don't need to on the test, but checking yourself in the homework, you would need to get an LCD here. All right, let's see what's next on this sheet we would have done in class. Integration of dx. Okay, now this one's particularly tricky because you're like, it just looks like only the operators are there. It's like, where's a variable or a number? So you have to remember, if there's nothing there, just like any other time, you would assume that it's a 1, right? So if this is Jeopardy and that's the answer, what would have made a 1? I hope you thought of it. It's an x. The derivative of x is 1, and then you just add the plus c. Okay, let's see what's next. Theta squared plus secant squared theta d theta. Okay, cool. So we're integrating in respect to theta, which means that theta is the variable that we're integrating with. And now we're also seeing a little bit of trig, which is good. So for the first theta, you would handle this. Some people get weirded out when it's theta, but it's the same concept if it had been like an x squared. All right, so theta squared, you're just going to add 1 to the exponent. So it's theta cubed, and remember, you divide by the new exponent, so you get that. Now trig, you have to go backwards. So you got to think to yourself, okay, if this is the answer to a derivative, who made it? Who made it? Go backwards. Okay, hopefully you figured out it was a tangent, because the derivative of tangent is that. And then again, just don't forget the plus c. So if I took the derivative of my answer, it has to give me this. That's the idea. Let me see if I can squeeze one more in here. I think I can in this video. We're doing good. Okay, number 6. This is a nice section to end on, just because it's not crazy difficult. And if you practice it, you'll do really well on this section on the exam. It's just, it's not very difficult to learn like maybe like word problems are. This section is much more straightforward. Okay, I just said previously that there is no quotient rule for integration. So we actually have to use our identities to collapse this. So we have to actually completely collapse this fraction. So try to think about what identity you could use for this denominator. Okay, I hope you thought about the Pythagorean theorem. I hope this one came to mind. Okay, this is the Pythagorean theorem identity. Now I just want to format it like this. So if you notice, you can fiddle with these. I'm going to move the cosine over here. So that would mean that this guy right here is equal to sine squared. So I'm going to go ahead and replace it. So all I'm doing here is rewriting. I'm not integrating anything. I'm not integrating anything. I'm just fiddling with my identities because this is not formatted correctly for me to integrate. I can't integrate this in this form, so that's why I'm fiddling with the trig. All right, now see if you can figure out what this might do. Like, how could we maybe rewrite this? And I'll give you a hint. I'll give you a hint. Hopefully that helps. You have two signs in the bottom, so I can break them up. So what does this guy here become? Okay, I hear you guys saying cotangent. Very good. And what does this guy become? I hear you guys saying cosecant. Very good. Okay. Now, who makes that? And this is a tiny bit tricky, but let's get the first part. So the derivative of this would be, good, cosecant. Now, the derivative of cosecant is technically negative cotangent, and since a negative isn't there, I actually have to negative the negative. So when I take the derivative of this and it becomes negative cosecant cotangent, this negative here will knock out the negative. And you could just see in the rules I showed you earlier that this would integrate to a negative. Okay, so that is the, oh, I wrote derivative. Look at me. Look at me. Integrate. We're integrating. So the integral of this is this. Okay, let me see what else we can look at. Okay, let me end this one here and I'll pick up again in another video. Okay, bye-bye.